Oh my God, it happened. All right. All right. So we have this lesson here. It's just the next lesson, and it's very related to what we were doing with multiplying rational expressions. So same approach as multiplying. Same approach. We're going to look to factor our terms, to cross things out, to cancel them out. The only difference is we're going to do the flip trick, which is multiplying by the reciprocal. Okay. So after we do the flip trick allows us to change it from being division to being multiplication. Okay, and you've probably seen this before with fractions. Um, we use this to change the operation going on, and that also allows us then to find the restrictions. We're going to look at the restrictions after. So, just a typical fraction here, 1/2 divided by 3/4. We would change that. We do the flip trick to make it 1/2 times 4/3, right? Remember this? So it's basically just changing it from being division to multiplication. And the thing that changes is that second fraction is always just flipped. And then with multiplication, as we had before, we multiply straight across and we get 4/6 or 2/3. Okay, so we get there. We're done. That's how we deal with fractions. Now, when we're dealing with expressions, which just include variables, we're going to first do the flip trick. The flip trick is going to get it set up to state some restrictions. So let's go ahead and keep the same fraction for the first one, then multiply, flipping the second one. And you could see right away that we're going to have a restriction here. X cannot equal 0 because X is on the bottom. If you were to plug in a 0 there, denominator 0, would you like one of my 0 cookies? Not cool. So we're setting it up like this. Can't decide what color to use. All right. So we're going to multiply straight across. Now, we multiply straight across, and we're going to get 9x squared on the top, 7x on the bottom, and we can reduce that one step further. Remember that x squared is just x times x, so we're going to be able to cancel out one of our x's on the top and one on the bottom. So what do we get? 9x over 7. You have to state the restriction as well as part of the answer. That's key. Don't forget that part. Okay, so the basics are we're doing the flip trick, that second fraction flips, and that allows us to go from division to multiplication. And then from there on out, it's the exact same lesson as or the one we did Tuesday. Okay, not bad, right? It's nice. I feel like these lessons, one after the other, has been just like one more baby step, and that's all we have here. We don't have too much more after this that's connected. We've got a couple other kind of separate topics, but rounding out the week, we've seen a lot of this before, so it's good. All right, so let's see. Let's go ahead and set up our next fraction. We're going to keep the first one the same. And we're not going to be able to see the restrictions for this first fraction right off the bat because we're going to have to factor this. But we can do the flip trick, and that allows us to just get one step further. So let's go ahead and factor this here, this trinomial. Let's factor it using the x method, and then we'll put all the restrictions. Okay, so I like to get them all ready. I mean, you could be marking x cannot equal 3 because you look here, x cannot equal 3. But let's go ahead and let's get them all ready at the same time. So I'm just going to do the x method right next to it. -6, -1. C, B. So B goes on top, C goes on bottom. We're looking to see what multiplies to give us -6. So let's see what multiplies to give us -6. Let's see, 6, -1, -1, -6, 1. Let's see, -3 and 2, 3, -2. Okay. So once you have all of the multiples of -6, the factors of -6 worked out, then you just ask what adds to give us -1, and it looks like it's going to be this one, -3, +2. I see how this is going to start to work out. Yes. So we've just factored this trinomial into these two expressions, x minus 3, x plus 2. All right. And when I look at that, now I need to go in and state what x cannot equal. X cannot equal negative 2, because look at this expression here. If we put negative 2 in for x, we get a 0 on the bottom of the fraction. You can't have that. So negative 2 is out. X cannot equal 3. Put a 3 there, you get a 0. Or if you put a 3 there, you get a 0. So we're going to say x cannot equal 3. You don't have to write it twice. So x cannot equal 3 for this, also this, but you don't need to write it twice. It's just one number. Okay. Let's see. The other thing that I'm seeing now that we can factor is on the top, x squared minus 3x. We're going to factor that as well, because what we can take out of both of those fractions, those terms is an x. If you factor out an x out of both of these terms, you get x minus 3. All right, so we just did a lot of factoring within that one line. Let's rewrite it so it's not messy. We'll put it all on one line. X times x minus 3, x plus 2. That's everything on the top. All right, and then on the bottom, we're going to end up with that x minus 3, x plus 2, x minus 3. All right. Actually, a lot is going to cancel out here. Go ahead and cancel all that out. Get your final answer. Circle it up with your restrictions. And we will... Oh, there's Angelina. Let me make sure she's in. Let me get her roll done real quick. Okay, welcome in, Angelina. I'm recording this, so I'll probably... no worries, no worries. Okay. I'll post the lesson in the stream, the video I'm recording right now for that. It's a real short lesson. It won't be much to review here. So again, the only difference was we did the flip trick, changing division to multiplication by taking the reciprocal of the second fraction. We went ahead and factored, so all our denominators were factored so we can see our limitations, our restrictions. X can't be negative 2, also cannot be 3. And now we have it all in one line. We also factored the top part, the numerator of the first fraction. But let's go ahead and cancel what we can. Nice. And we end up with our final bit. On the top is x, on the bottom is x minus 3. And that is going to be the final answer. So you just got to put the restrictions. The restrictions you always find after, okay? After. Restrictions always come after. So I'll even write that there. Restrictions after flip trick. It's not really a trick, but all right. So any questions? I feel like it's like a repeat of last lesson. The only difference is you flip, you do the reciprocal of the second fraction and then find restrictions. That's the only difference really, guys. So I'm going to go ahead and wait. Yeah. Yes. It's always going to be the second fraction. Because think of a division problem, right? A division problem is like up here. You know, if I change this up and it was 6 divided by 2, right? 6 divided by 2 is different than 2 divided by 6. Okay. So with division, with division, we have to keep in mind that they aren't interchangeable. With multiplication, after I get it down here to multiplication, or any multiplication of two values, we can interchange. But with division, it's the first term or expression divided by the second term or expression. That's why we can only do the flip trick and flip that second fraction involved. Okay? And I can't think of a scenario where you'll have where you'll have 3 different fractions. That's not really going to happen. But that wouldn't be that bad. You would just isolate the first 2 and then work on the other leftover 2. Any other questions coming up? That was a good clarifying. It's always the second one that we flip. Always. It's nice when things are always. All right, that was a 10-minute lesson. I'm going to go ahead and stop the video and check in, see